Hello, welcome to the next episode of P4Edge Tutorial Series. In this video, I will show you how you can use a filter-based firewall on your P4Edge-based access point. So I assume that your device is in access point mode, so our laptop can connect to it via Wi-Fi, and the P4Edge node is connected to your home router via cable in a wired way. So I have already switched my device into this mode, so you can see here, and or you can watch our previous video about it, how you can do that. And I got a new IP address from my home router, so I will use this IP address to connect to my device. So I open an SSH session, and yep, I had already launched the layer 2 switching example, and if it works, we have internet connection actually via the P4Edge device. So we can check it, for example, with the website. Here, everything is working. And so what I will do now is to execute a new example, which is called traffic filter. It implements a simple filter-based firewall, and we will add this functionality to our access point. So I will do it manually, however, it can be easily done via the web interface as well. And I do that manually because I would like to show you how you can use standard P4 runtime tools that can implement the control plane functionality to fill the tables manually using this P4 runtime shell. This P4 runtime shell can also be used as a library, so you can also create your own control plane application using that library and connect to your P4Edge device with this, and modify the tables, fill entries, add entries to the tables, or remove entries, and so on. So basically, the configuration, the filtering rules will be provided to our P4Edge device in this way. So first, I switch to root context and go to the root folder. I will use the traffic filter P4 application. It has already been deployed on the device. It's part of the examples. And you can find more details about it on our wiki page. Okay, so it has already been added. I execute the or restart the Tapas backend. Okay, sorry. We did restart. And if it is restarted, then we can also check the, yeah, it has already been launched. And there's a command on the device. It has already pre-installed, which is called Tapas P4RT shell. This is the P4 runtime shell that we can use for controlling the tables and doing table manipulations manually. Basically, if you modify the tables via the web interface, it is also using the P4 runtime shell in the background in a bit different way. But we can do it manually. There are two scripts for wrapping the P4 runtime shell. One is developed for Tapas, and the other one is for BMV2. And the two scripts are called Tapas P4 runtime shell and BMV2 P4 runtime shell, and you can use it similarly. It expresses one command line argument, which is the name of the P4 program that is executed at the moment. You can also use your program name if you have already deployed your program, so you can use it with this P4 runtime shell automatically without any differences. So I will execute P4 runtime shell for this traffic filter program. So I say that it's traffic filter, and it starts running and it managed to connect. So if there are some failure with the connection to the P4 programmable switch, then you get an error message here. If you get the prompt, it means that you managed to connect to the device, and you can check And in this P4 program, we have different tables, and we can use these tables to add different filtering rules. We can provide filters on many fields, including the MAC addresses, IP addresses, TCP ports, TCP source destination ports, UDP source destination ports, etc. And in this demo, or in this example, I will provide a filter on port TCP port 80 on the destination, and we can see that currently we have internet connection via this device, so we can check it again, and it works very well. And after filtering out TCP port 80, basically our traffic will be blocked, so it should happen. So how we can do that? So first we create a table entry which will be added to our P4 program, and we will modify one table which is called TCP destination port filter, and the action which will be executed in case of filter will be a packet drop. So we will use this action. Okay. I missed the table name actually, but we can list it using the tables command. And we can see that the problem was here actually. And I hope now it's okay. I made another mistake, and now it's perfect. So we can say that okay, now we created an entry. We defined that which table we are focusing on, so where to insert the entry, and we also provided the action. However, we have to define the matching rule. So I will say that the match will be on header TCP destination port, and the value will be 80. And basically that's all, and after that we can insert it. If we have, let's say, action parameters, we can also define them, but currently drop has no action parameters, so we can simply insert this into the table. And let's check if the web server access is blocked or not. So we blocked port 80, and let's see. Okay, it's still working. However, if you have a look at the URL, it's using HTTPS, which uses a different port. So I go back to HTTP. The website is available on the standard 80 port as well. It will be redirected to HTTPS, but it's still working. And now we are not able to connect because it was filtered out. And you can also see that all the other traffic is working. I can, let's check pinging a website or a remote IP address, and you can see it still works. So ICMP packets are not affected, and only HTTP is affected. So you can also test this filtering functionality with another website. So there's a portquiz.net website, which is listening on port 80 by default. So it uses HTTP instead of HTTPS. And if we go to the portal, it's still loading and loading, and I guess nothing will happen. So because all the packets going to port 80 will be filtered out by the access point. Okay, and if we delete the entry, so we edit and we can delete the entry, and I go back here and the page is refreshing and we get back the portal. So this is listening on port 80, but this portal can be used for checking different outgoing ports, so you can play with it. So thanks for watching and happy hacking.